Good afternoon, students. So, some internet problem. The class is resent to you. Okay. We shall continue our discussion on chemical reactions of alcohols and phenols. See, in chemical reactions involving alcohol, carbon to oxygen bond and oxygen to hydrogen bond. Two bonds cleavage takes place. Alcohol can act as a good electrophile and as well as a nucleophile. Are you clear? See, first we shall concentrate on the cleavage of oxygen to hydrogen bond. See, alcohols when reacts with active metals. See, we shall discuss about chemical reactions of chemical reactions of alcohols. Chemical reactions of alcohols. See, when alcohol reacts with ROH, when it reacts with active metals like sodium. See, we will get 2RONA, which is nothing but sodium alkoxide with the release of hydrogen gas. So this chemical reaction indicates that alcohols are acidic in nature. They behave as an acid. Take for example, we go for the phenol. Again, phenol reacts with the active metal like sodium. Two molecules of phenol, 2Na. We will get sodium phenoxide. We will get sodium phenoxide ONA plus hydrogen gas. In both the equation, you can see the release of hydrogen gas. It indicates that the phenol are good acid. Are you clear? They are very good acid. Again, so this is one type of reaction. So we shall study the acidity of alcohol and phenol. Acidity of alcohol and phenol. In acidic character of alcohols, see alcohol ROH. Are you clear? See, it can split into RO minus plus H plus. See, alkoxide ion is formed. Whatever the oxygen which is bonded to hydrogen, oxygen is more electronegative, and you can find ionization as soon as hydrogen atom releases in any aqueous solution or in any solution, then it acts as a very good acid. It behaves as an acid. See, if you go for phenol, so this is one phenol OH. Here, the oxygen atom behaves as an electron withdrawing. The electron density releases to. The electron density releases to. This will become minus, and this will be to double bond and partial positive character of oxygen atom. So these are the two bonds. See, hydrogen atom can easily release out. Therefore, phenols are more acidic than alcohol. Very important point you have to remember. Phenols are more acidic than alcohol due to the resonance structure is formed. See, you can write resonance again here. See, negative charge on para position. See, these two are the double bond, and this partial positive charge, and this is the word H. See, again we have the resonance structure of phenol as Negative charge is here, and this will be double bond, and this is partial positive charge, and finally you will get phenol. So this is the thing that we know. Are you clear? So this area, and again, as it is a double bond, this will be received. So this is nothing but a resonance structure we have. So you must capable to write phenol is more acidic than alcohol. Are you clear? Phenol is more acidic than alcohol because in phenol the oxygen atom is bonded to sp2 hybridized carbon of a benzene ring, and then act as this oxygen atom as electron withdrawing. So therefore hydrogen atom can easily ionize, can easily form. See, as more number of hydrogen releases in particular solution, it will become more acid. Automatically, it will become more acid. So that is the thing we have to remember about the acidity of alcohol and phenol. You have to compare again. See, when hydrogen atom releases, you will get a phenoxide ion. You have to compare the acidity of phenoxide ion also. The acidity of phenoxide ion is phenoxide ion. Say, phenoxide ion and phenol. You have to compare. So this is nothing but a phenoxide ion. Phenoxide ion. O minus. Are you clear? And we shall write phenol. We shall write phenol. And this is nothing but phenol. You can see. This is phenol. Among these, you have to check which is more stable, which is more acidic. Among the phenoxide ion and phenol, phenoxide ion, and phenol. So phenoxide ion is more stable, more stable. See, as negative charge is here, again you can find resonance also. Phenol resonance you already studied. Are you clear? So you can easily compare the phenoxide ion as well as phenol. Are you clear? As this will become, see, these lone pair, again double bond character, you can easily write the resonance. You can easily write the resonance of phenoxide ion. See, here again minus, and this will become double bond, and this will be double bond, and here it is double bond, and minus is there. And it is a partial positive. Then it goes here, and it's another resonance is, can easily write C2 double bond, again O minus, like that it charges here. So this is nothing but its resonance. It's a resonance. These indicates that phenoxide ion as negative charge is stable, which forms a double bond, and it is more stable than phenol. Phenoxide ion is more stable than phenol. Okay, you have to compare the acidic strength of phenol, with electron withdrawing and electron donating. See, in electron withdrawing. So this is nothing but phenol. If this phenol contains the groups like NO2 or COOH or CHO, or these are electron withdrawing. As they withdrawing, or here it also receives. At that time, this can be easily released. So therefore, any electron withdrawing group is present on benzene ring, then they are more acidic. If electron donating groups like CH3 or C2H5, is present on enzyme, then here acidity decreases because electron is obtained from the group only. The release of H atom is less. So therefore, the amount of hydrogen in any solution is very less. So therefore, acidic strength automatically decreases. We can easily compare. So generally, analogy you have to remember is if any group withdrawing group is present on phenol, then automatically its acidic strength increases. If electron donating groups are there, then its acidic strength decreases. That you have to remember. So you have to compare the examples of see meta nitrohexane, then even cresol. In cresol, see where CH3 group is there, at that time it is an electron donating group. The oxygen and hydrogen atoms are morely held tightly. It cannot release hydrogen as possible. Are you clear? So therefore, its acidity decreases. See, as pK, compare the pKa value of, if the pKa value is less, then it is more acidic. More acidic. If pKa value is more, then it is less acidic. Are you clear? If electron donating group is present on ortho para-dialectric group or in a meta-dialectric group, see ortho para group, we can find it is more acidic. Are you clear? So you can easily compare the acidic strength of alcohol and phenol. Dear students, you have to remember alcohols are less acidic than phenol. Are you clear? Again, phenol and phenoxide ion. See, phenoxide ion is more stable than phenol. Okay. If you compare alkoxide and phenoxide ion, alkoxide where the partial negative charge is static, again there is no resonance again. Okay. Phenol is more stable than alcohol. That means more acidic than alcohol. Okay. So we completed the study of what? The acidic nature of alcohol and phenol. We shall study other chemical reactions, which is nothing but esterification. We shall study esterification. Esterification. Are you clear? See, in esterification, when an alcohol reacts with carboxylic acid. See this carboxylic acid, I will write in this line. See, COH, which is nothing but an what? Carboxylic acid. Now I am going to write, say, OH again, CO. So this, which is nothing but an water molecule, in the presence of an acid, concentrated H2SO4. Alcohol on heating with carboxylic acid in the presence of concentrated H2SO4, and ester is formed, RCOR, which is nothing but ester plus water molecule, and it is a well-known, very simple and familiar chemical reactions of an alcohol. Alcohol reacts with carboxylic acid. Alcohol reacts with carboxylic acid. In the presence of concentrated H2SO4, an ester is formed. This particular reaction is called esterification. We will ask for 2 marks. What is esterification? What is esterification? See, alcohol reacts with carboxylic acid, In presence of concentrated H2SO4, an ester is formed. This particular reaction is called esterification. It is called esterification. Are you clear? Okay. Then see, instead of carboxylic acid, we can also use say alcohol when it treated with say RCO twice with acidic anhydride, which are called anhydride. And again, same we will get. So you will get RCOOR dash. Okay. If it is acid anhydride alcohol, when it reacts with acid chloride like COCl, acid chloride, or even acid amide, then you will get in the presence of pyridine. We have to use pyridine base as a catalyst in presence of HCl. See, HCl is released when alcohol reacts with acetyl chloride. When alcohol reacts with acetyl chloride, so we will get an ester RCOR dash. So we have to use here pyridine because say HCl is absorbed by a base. HCl is absorbed by a base. And these type of all three types of reactions are called esterification reaction. Esterification reaction when alcohol reacts with carboxylic acid, acid anhydride, and acid chloride. Are you clear? So we will find ROH plus ROCl in RCOR dash and HCl. Again ROH, RCO twice more, RCOR dash, and this is nothing but an ester. Are you clear? So dear students, due to some internet problem, one class which I started just for 10 minutes, it relayed only 10 minutes, and now I am going to stop here due to some internet interruption. I will continue my class on tomorrow. Thank you.